So in this lesson we're going to graph linear equations. There are three forms of linear equations. The first is our slope-intercept form. So our equation should look like this. Y equals mx plus b, where m represents our slope and b represents our y-intercept. Now the equation just reads slope-intercept form, but this is technically the y-intercept. The second form here is standard form, which is ax plus by equals c. And our third form here is y minus y sub 1 equals m times the quantity x minus x sub 1, where x sub 1 and y sub 1 are just two coordinates or a point on the graph somewhere. Now, if you look at this, the point slope form. The point comes first, the slope comes second in the equation. Makes it a little easier to remember this form. Slope-intercept form, again, the slope is m, b is the y-intercept, so slope-intercept form, and standard form is probably just the only one you have to memorize, ax plus by equals c. Now today we're going to concentrate on the first form here, y equals mx plus b. So let's take a deeper look into this form. So we have y equals mx plus b. Alright, so the m, again, represents the slope of the line. Okay, so let's think about what is slope again. Okay, so the slope is defined as the rise over run of the equation. So the rise over the run, also notated in some books as the change of y over the change of x. Now, what do I mean by rise over run? Okay, let's concentrate on these two aspects here. The rise over the run. The rise is any vertical change. So am I moving up or am I moving down? The run is, am I moving to the right or am I moving to the left? Now let's follow a few easy steps. Okay, so our first step here is we're going to select 2 points on this graph. Now the 2 points I want to select 2 points that are right on the intersection. So if you highlight this point here, this point falls right on the intersection of the graph. And if we look at another point on the graph, this point here is a point that intersects right on the center of the grid. Okay, so these are 2 points I'm going to select. Second step here I'm going to do is now find the vertical change. Now, I want to know, how do I get from this first point to the second point in a vertical movement? Do I need to move up or do I need to move down? Well, in this equation here, you should see I need to rise 3 units, or let's say I'm going to go 1, 2, 3 units up, and then this will get me level to this point. It doesn't bring me to the point, but it brings me level to the point. So this is a rise of positive 3 units. And it's positive because I went up. Anything in the upward direction is positive, anything in the downward direction is negative. And similar to the left and right, anything in the right direction is positive, just like your number line. Anything to the left direction is negative, also like your number line. Okay, so up is positive, down is negative. Right is positive, left is negative. Now, I rose 3 units, 1, 2, 3, bringing me here. Now I want to ask myself, well, how many more units do I need to, or now which way do I need to move in order to get to this next point here? Well, starting from this area here, I need to move to the right 1, 2 units to the right. So I'm moving to the right 2 units. Therefore, I can say this is going to be a positive 2 run. So from this point to this point, I had to move to the right 2 units. This denotes my run. The positive 3 was my rise. So this line here was my rise. This line here was my run. So positive 3 over positive 2. Now, that was the horizontal change. So that was our third step. Now let's simplify this. Let's say m equals Our rise, we said, was positive 3. So positive 3 on my rise. Over my run, we said, was moving to the right direction, so positive 2. So positive 3 over positive 2 is just simply 3 over 2. In this case, you do not need the positive sign since they're both positive. Let's get rid of that. So our slope here is 3/2. We'll look at more examples to come. The b, so y equals mx plus b, is the y-intercept. This is any point that falls on the y-axis. Now this point must fall on the y-axis. So in this case, the point that's exactly on the y-axis that crosses that's on the graph is right at this location here. The coordinates to this point are going to be always 0, comma, some number. In this case, this is 0, comma, -1. Okay, so the y-intercept here is the -1. It's the point that lies right on the y-axis. Okay, and always on the y-axis. And again, the x value of this y-intercept is always going to be 0. So if you see a coordinate with the ordered pair 0, comma something, that is your y-intercept. This is also known as your initial value. Your slope is also known as your rate of change. So again, the b is the y-intercept or the initial value, and the m is again the slope or the rate of change. Okay, either one. Let's take a look at some graphs. So given a graph, y equals x minus 1, we want to graph this equation. So first, we want to graph the y-intercept. What is the y-intercept? Well, y-intercept here, a good idea here would be to write the y equals mx plus b right on top. And we can see from this equation, the -1 is my y-intercept. So let's do that first. Let's graph that point there, -1. Now we have my initial starting point. Now where do I move from here? Well, my slope is going to tell me. What is the coefficient in front of the x here? Well, technically we don't see any number or in front of the x or any coefficient in front of the x. So when there is no number there, we have to assume there's going to be a 1. So that 1 becomes my slope. Now we're going to use our slope to find the next point on our graph here. Now if your slope is a whole number, it does not have a fraction, let's create a fraction. So we got b is equal to -1, and we said m is equal to 1. Let's make this a fraction, 1 over 1. So every whole number is over 1. So again, this is my rise, and this one here is my run. Now since the 1 is positive, I'm going to go up 1, and since this 1 is positive, I'm going to go to the right 1. So counting from here, now these lines here you don't have to technically draw in, but I'll draw them in for now. So I'm going to go up 1 unit and to the right 1 unit and make a dot. Again, I'm going to go up 1 unit to the right 1 unit, make another dot. And this will go on forever. Up 1, right 1, and there's a coordinate. Up 1, right 1, and there's another coordinate. Now this line or this slope should follow a pattern of a linear line. Okay, there shouldn't be any twists or turns or curves on the line. It should just be a linear line here. Now again, these pieces of information here are not needed. This is just more for a visual, so you can get rid of these pieces. If you're drawing with a pencil, just draw those very lightly, or once you get the hang of this, just kind of follow your pencil all the way through. Alright, so let's take a look at how this works in the table. So this first coordinate here is 0, -1. The second coordinate here is actually 1, 0. The third coordinate here is actually 2, 1. The fourth one here is 3, 2. And the fifth coordinate we have here is 4, 5. Let's just pick any one of these points. Let's go with any one of these points. So let's go with the 3, 2 here. So let's highlight this one, 3, 2. Now the x value, you have your x and you have your y. The x value is your input value. So we want to take this equation, y equals x minus 1. So this is the place of the x. So rather than inputting an x here, we're going to get rid of this x, and we're actually going to input the 3. So let's take this 3 and input it into this function. And let's solve this equation. So we have y equals 3 minus 1, so y equals 2. Whatever your result is here, this is known as your output. So we input 3 into the function, and we got an output of 2. So the input, output. The input is your x value, the output is your y value. So did this confirm? When we did this mathematically, did I get 2 just like I got my graph? Well, yes. So when I input 3, I should have gotten an answer of 2 like my graph stated. And again, you could test all these points here, any one of these points. So if you test this one, if you input, so let's test this one. If you input 1 into our function, well, let's input 1 here. 1 minus 1, does that equal 0? Yeah. So that verifies that's correct as well. And this last point here, so here's a mistake I made. 4-3 should have actually been 4-5 should have actually been 4-3, and that's how you could catch your work too. So if I input 4 into the function, it should get an output of 3. So when x is 0, y is negative 1. When x is 1, y is 0. When x is 2, y is 1. When x is 3, y is 2, and so on. And if you notice the pattern here, this is always increasing by 1. And it should follow the same pattern all the way through, and that's what makes a linear equation. Having no curves to the line, and all your patterns are always equal or always the same. Let's take a look at the next example. Y equals 2x plus 4. Okay, so again, let's follow these quick, easy steps. Let's graph our y-intercept. So now, again, I'm going to write y equals mx plus b. And this is completely optional, but I would definitely do this in the beginning. So m equals 2, and we got b equals 4. So my y-intercept here, we're going to go with this one first. My y-intercept is 4. So on the y-axis, this is the coordinate 0, 4. That takes care of that part. Now, if we have a whole number, if my slope is a whole number, let's just put it over 1. Okay, for graphing purposes, let's put that over 1. So the 2 here represents the rise, and the 1 represents the run. So my 2 is positive, so I'm moving in an upward direction. My 1 is positive, so I'm moving in to the right direction from my y-intercept. Okay, so again, you don't have to draw the lines, but from here I'm going to move up 2 units, and I'm going to move right 1 unit. And those lines are completely optional, and then plug your point. So not until you move both the rise and the run do you put your next point in. And again, this will rise up 2 and run 1. If you kind of go backwards, you can see that to get from this point to this point here, well, how do you go backwards in a sense? Well, you can actually, from one point to point, you could go down 2 and the left 1, down 2, left 1, and you can keep following that pattern as well, and you go down 2, left 1, down 2, left 1, and you can follow that pattern as well, and you can see that you again create a perfectly vertical line here, and you could test these points and make sure you are correct. So let's write some of these points down. So our first point here was 0, 4, which is the y-intercept. Let's take the next point here. Let's concentrate on this point. This point here is 1, 6. And let's take this point here as well. We'll concentrate on this point. This was the point -1, 2. So if I input 1 into my function, I should get an output of 6. If I input -1 into my function, I should get an output of 2. Let's test to see if that's correct. So we got y equals 2 times whatever my input is plus 4. Now my first input here, we're going to plug in 1, and we should get an output of 6. Is this true? 2 times 1 is 2, plus 4 equals 6. So my first one checks out. let's take this next one here. Let's plug in this input here, -1. So 2 times -1. 2 times -1 is equal to -2 plus 4. -2 plus 4 is equal to 2. That one checks out. So now we have verified that both these points work, and the rest of the points should work as well. Again, so if you have a graph here, you can actually use those coordinates. So you have first coordinate 0, 4 from your y-intercept, nice and easy. You have coordinates like 1, 6. You have coordinates like -1, 2. And typically when we write these, we should put these in descending order. So let's use your inputs in descending order from least to greatest. So -1, 0, 1, 2, 4, 6. And if you notice the pattern here, increasing by 2, increasing by 2, and my x values are increasing by 1. So as long as my x values are increasing by the same number, my y values should be increasing by the same number as well. So our first step was to graph the y-intercept. Secondly, we use the slope to find the next points in the graph, and simplify the slope or check your work if anything. And you can check your work again by inputting each value and making sure you get the correct output. Let's take a look at another example. Y equals -3x minus 1. Okay, so I'm going to take a couple shortcuts on this one. We're going to say, okay, my slope here is m equals -3, and my y-intercept here is b equals -1. So again, let's start with our y-intercept, -1. Let's pop that point in. This slope is a whole number, or is a integer. It doesn't have a fraction. Let's make a fraction over 1. So if we concentrate on this, this is -3 over 1. Now it doesn't say what kind of 1, so we have to assume it's just going to be positive 1. So -3 again is my rise. So if it's -3, am I going up or down? Well, anything that's negative is going in the downward direction, so I'm going to go down. And then my positive 1 on the bottom is my run. Well, it's still positive, so I'm going to the right. So looking at this this first point here, my y-intercept, I'm going to go down 3 units. So 1, 2, 3, and to the right 1. Remember, this line here that I just drew, this is a line that you really don't want to draw on the graph. It's more just for visual purposes. And let's keep going and do another point. So we can go down 3 again. 1, 2, 3, right 1. So notice, this is -3 over positive 1. I could actually flip-flop these two as well. So rather than writing -3 over 1, I could actually write positive 3 over -1. And all I did is just change the location of the negative sign. Rather than giving the negative to the numerator, I now gave it to the denominator. So now I could go up 3 units from here. So 1, 2, 3, and to the left 1. 1, 2, 3, and to the left 1. And again, this should follow a nice linear line with a slope of -3 and a y-intercept of -1. Again, you can check your work. You can check your work here using these 3 steps. Graphing the y-intercept, use the slope to find your next point, and then check your work by inputting and make sure you get that same output. So again, we could check one of these points. So we have an input of, so this coordinate here is -2, 5. So again, we have an input of -2. So let's input -2 into our equation. So y equals -3 times -2 minus 1. And if all goes well, when I solve this, I should get an output of 5. So y equals -2 times -3 is positive 6 minus 1, which equals 5. Y equals 5. So here we are, we got that correct. Next example. Y equals 3/4 x plus 4. Okay, so now we have a slope as a fraction. So in this case, it wasn't a whole number or an integer as before. So we don't have to create a fraction here because it's already done for us. So we have 3/4. We don't have to put it over 1. It's already there. And my b again here is 4. So again, following my 3 steps here. Graph our y-intercept. Use slope to check your next point, and then check your work. So we're going to graph a y-intercept here of 4. So let's go up to 4. 1, 2, 3, 4. And then the slope here. So this is positive. This is positive. So I'm going up 3 to the right 3. Or, since they're both positive, I can now make these both negative. So I can say -3 over -4. because when I simplify these two fractions, positive 3 divided by positive 4 is still positive 3/4. Negative 3 divided by negative 4 is still equal to positive 3/4. So as the last example, I was able to flip the negative sign. I was able to give the negative sign to the numerator, leaving the denominator positive, or on the other hand, make the numerator positive, make the denominator negative. This example, since both numerator and denominator are positive, I could make both numerator and denominator negative. So let's use that. So let's use with the positive one first. We got up 3 to the right 4. So 1, 2, up 3. 1, 2, 3, 4. Going to the right 4. Or I could go down 3. 1, 2, 3. And 1, 2, 3, 4 to the left. And you notice here again we have created here a linear line. Am I correct? Well, what is this coordinate here? This coordinate is the coordinate 4, 7. And this coordinate here is the coordinate negative 4, 1. If we use our function here, y equals, and let's see if we'll test this out. Let's move this over a little bit here. We'll shrink this down to size for a second. So we'll say that y equals 3/4 times my input plus 4. I guess we'll go with this one first. Let's input negative 4 here. Y equals negative 3/4 times negative 4, so this is like negative 4 over 1. My x and y simplify here. Let me just take this for a second. So I have some simplifying here. So negative 4 and 4 gives me negative 1 simplified. 3 times negative 1 is negative 3 plus 4, and negative 3 plus 4 is 1. Go back and check. Does my output equal 1? Check. That one works. Beautiful. Let's take the next one. Let's move this over here. Now let's input the 4. So 3/4 times my input 4 plus 4. So we'll make this 4 over 1. My 4 simplifies, so I got y equals 3 plus 4. Y equals 7. And we verified that that point works as well. So again, y-intercept, plug it in, first step. Use your slope to find your next point. It'll give you directions. Remember, you always have two different directions. And finally, you can check your work by inputting the input in for x and solving to make sure your y value is your output and they correspond. Okay, we're going to skip this one. We're going to go one more here, or 3 more to go. Y equals 2x. Now this one's a little different. So we have y equals mx plus b. Now there is no plus b here. So when there isn't any plus b here, you have to assume that this is going to be plus 0. So my slope here is 2. My y-intercept here, or my b, is equal to 0. So when this equals 0, this is actually going to be 0 right at the origin. And just like before, this is 2 over 1. Rise 2, run 1. This is positive. This is positive. So rise 2, run 1. Rise 2, run 1. They're both positive, or we can make them both negative. Negative 2 over negative 1. Down 2, left 1. Down 2, left 1. And notice that this always has to form that linear line in order to be true. Okay? And again, you could check your work here again. Two more functions, or 2 more equations, and these are a little special case. So we have the equation x equals 2. Alright, so this doesn't really fit the y equals mx plus b. Right? This kind of goes away from this. But this still has a graph to it. So let's make a graph here for a second, or an x and y graph. Now, this is saying x equals 2. Well, x in this case will always equal 2. Regardless of why y was equal to, this will always equal 2. So, you know what? Let's drop a few points here. Let's say 2, 2, 2. So, x is always 2 regardless of y equals. So let's pick some random arbitrary points for y. What do you want to pick? We could pick -1, 0, and 1. Okay, I like to keep my numbers small. So now let's graph these two. Let's graph these points here. 2, -1. Okay, so we're going to go 1, 2, -1. 2, 0. Okay, 1, 2, 0. 2 comma 1. 1, 2, comma 1. You want to pick another value for y, so x is 2. Let's say y is 7. 1, 2, y is 7. So if you notice, this line now becomes, if you draw a line through all these points, when the equation is or x equals something, or any number, x equals 2, x equals 3, x equals 4, it's just a vertical line exactly through that coordinate or that corresponding number. So x equals 2 would look like so. If you had an equation that was like x equals -3, well then you would just have simply a vertical line going through x equals -3. Okay, so this line will correspond to this. This x equals 2 corresponds to this. And again, x equals whatever, x equals any number, is just a vertical line going through that x value. Well, the opposite of a vertical line is the horizontal line. So in this equation we have y equals -3. So the opposite of x equals something is kind of going to be y equals something. So let's take a look at our graph here. So this is saying no matter what, y is going to equal -3. So let's just drop 3 or 4 points here for -3 for y. And let's pick some random points. Let's say -2, 0, and 5. So if we plot these points, -2, -3. So we're going to go left 2, up 3. Not moving anywhere. 0, -3. There's a y-intercept. And right 5 and up, down. I'm sorry. This should have been left 2, down -3. Not moving, down -3. And our last one, to the right 5, down -3 again. So now if you notice that this equation created, we created a horizontal line going through the value of -3. Now again, this number y equals, this graph will always look the same. So if you had something different, you said y equals, let's say 5, then in this case you would have a horizontal line going through the y equals 5 number.